Okay, so in this video, we are going to start with the worksheet which is related to periodic table. So, which three elements exist as diatomic molecules at room temperature? So, first of all, if we see that this is basically uh, a monoatomic gas, okay? This is also a monoatomic gas because they belong from group 8 and they are noble gases, okay? And here, this is also a monoatomic gas. Why we are calling them as monoatomic gas? Because they don't combine with any other atom, okay? As their outermost shell is complete. So their outermost shell is complete. Outermost shell is complete, so they don't make any other covalent bond with any other non-matter. Is complete. Okay. So, but if we see about nitrogen, oxygen, and fluorine, they all exist as diatomic molecule like N2, O2, and F2. So they all are diatomic. Okay, so let's move further. Which is a property of a halogen. Halogens are group 7 elements like fluorine, okay, chlorine, bromine, iodine, and astatine. Okay, so they all basically exist as diatom. Okay, so what happens? The atoms decrease in size down the group. No, this is wrong because the size of atom increases down the group. Okay, so there is another option that states that their melting point increases down the group. Yes, it is right because this exists in the state of gas, then liquid, then there is solid. So you can see if their state is basically changing from gaseous to solid state, so that is true that their melting point also increases down the groups. This option is right. They conduct electricity when molten. No, this is not true because they all are non-metals and non-metals do not conduct electricity. Okay, their silver salts are all soluble in water. This is wrong because their salts are insoluble in water. So let's move towards the next question. Part of periodic table shows the position of four elements. They are not the elements' actual symbols, and which element has a high melting point and variable oxidation state. So you can see that this is basically the characteristics of transition elements. Transition elements, and we have read about transition elements that they exist between group 2 and group 3. So we will say that this is basically transition element. So group 2 is basically this one and group 3 is this one. So the element that exists between them, that is basically a transition element. Okay, and transition metals, they have a property that they have high melting point, okay, and they have variable oxidation state. Now, let's move further. A lump of element X can be cut with a knife. Describe its reaction with water, X floats. During its reaction with water, X floats and melts. What is X? So this is basically the property of group 1 elements that they are soft and they can be cut with a knife. So group 1 elements are also called as alkali metals because they react with water and they float on its surface and form alkalis. Okay. So this belongs from group 2. This is a transition metal. This also belongs from group 2. And this is the only one which is group 1 metal. Now let's move further. Chlorine is passed into separate samples of aqueous potassium iodide. So chlorine is reacting with aqueous potassium iodide. Okay. And here chlorine is reacting with uh, potassium bromide. Now, the reaction will only take place if chlorine would be able to displace bromine or chlorine would be able to displace iodine. And for that purpose, chlorine must need to be more reactive than iodine or more reactive than bromine. If you see group 7 elements, fluorine, chlorine, bromine, iodine, okay, we have seen that their reactivity decreases down the group. Reactivity decreases. Okay, that means fluorine is the most reactive one. It can displace bromine or iodine, and chlorine is the second most reactive one, which can displace bromine and iodine. So this reaction can occur, and it can displace iodine and can displace bromine because it is more reactive. So option A is said to be the right one because in option A, they are saying the color change would occur because in that state, chlorine would be able to displace iodine and chlorine would be able to displace bromine. So let's move further. Some properties which indicates the difference in metals are listed. Metallic property, the number of electrons shell in an atom, number of protons in an atom, total number of electrons in an atom, which two properties increase across a period of the periodic table. So what happens, as I have told you earlier, that metallic properties decreases when we are moving from left to right. So left to right, what happens? Left to right, non-metallic properties increases. Non-metallic properties increases, okay? Increases across a period. So what happens if you see here that they are saying across a period, so metallic properties doesn't increase across a period. In fact, non-metallic character increases across a period. The number of electron shell in an atom, no, this is also wrong because number of electron shell would remain same across the period. We have seen this thing. So, like for example, lithium would be having two electron shells. Same boron would also be having two electron shell. Carbon would be having two electron shells. So, electron shell would remain constant throughout the period. So, this would also not be the answer. Number of protons in an atom. Yes, number of protons in an atom increase across a period. You can see number of protons here are 21, here is 22, here is 23. So they increase across a period. So this option seems to be right. Number of electrons in an atom, that is also increasing because if number of protons are increasing across a period, then number of electrons would also be increasing. So option would be 3 and 4. So this one would be the right answer. Seventh question. Germanium is in group 4 of the periodic table. So germanium is an element which is present here. This is group 5. This is group 6. And selenium is present in group 6. It has 32 atomic number and it shows atomic number of 34. Which period prediction can be made because on the position based on the position of germanium and selenium in the periodic table? A germanium atom has two more valence electrons. No, it's wrong because this selenium would be having two more electrons. So this is wrong. Germanium forms G plus 3. No, it can't form because it forms Ge plus 4 or minus 4. Then we have selenium that is minus 3. No, it's wrong so, because it belongs from group 6. So it had to form germanium -2 charge would be put here. So this would also be, sorry, selenium -2 charge. That would be selenium -2 charge. Okay. So that would also be wrong. Germanium has more metallic property than selenium. Yes, it's right, because we have seen that non-metallic properties increase from left to right, while metallic property increase from right to left. So metallic property increase from right to left. So germanium would be having more metallic character. That is the right option. Okay, because as it is on the left hand side, so we can say that it would be having more metallic character as compared to selenium. Proton number of cesium is 55. If we see proton number that is 55, then if we see periodic table here, so 55 would be indicating like just wait. Yes, cesium is okay. So cesium also belongs from group 1. Cesium belongs from group 1. And the reaction of potassium with water is uh, dash. So what happens? First of all, let's talk about melting point of cesium. So we have seen that melting point in group 1 that also increases down the group. So cesium is higher. Like melting point of cesium is higher. So option can be this one and can be this one. And the reaction of potassium with water is less vigorous, because we have seen that reactivity increases down the group. So that is why cesium would be more reactive, would be more reactive than potassium, more reactive than potassium. And the reason is that cesium is present down the group. Okay, so that is said to be more reactive. So this option is right, this option is right. The number of valence electrons in cesium is same. Why it's same? Because they belong from same group. Cesium and potassium belongs from same group. So they would be having same valence electrons. Valence electron means the number of electrons in the outermost shell. So that would be same. So option A is the right one. Then move further towards nickel is a transition element. Transition elements have some properties like they can be used as catalyst, and they would be having like variable oxidation state. Okay, and they form colored compounds. They form colored compounds. So these are unique properties that are associated with transition elements. And which option states that can be used as a catalyst, can conduct electricity when molten, uh, like this can be included in them, but it is not like the general property, because it's the property of most metals. So then it forms colored compounds, unique properties, it has variable oxidation. So 1, 3, and 4 would be the right answer for you. This would not be the answer because it is not a unique property. It is the characteristics of most metals. The diagram shows part of the periodic table, which two elements represent that they can react to form covalent compounds. So covalent compound is always formed Covalent compound is always formed between two non-metals, and non-metal here are Y and Z. So Y and Z is stated by this option because this is a transition metal, and this is basically group 2 metal. So if they form a compound with W and Y or W and Z, then that would be an ionic compound, not a covalent compound. Which statements about some of the elements in the periodic table is correct? The element germanium in group 4 has less metallic properties than in group 2. Yes, it seems to be the right one because the metallic properties decreases across a period. Okay, so germanium would be having less metallic property and more non-metallic character So this would be the right option. Okay. Now let's move further. This statement are about the halogens. All halogens are non-metallic diatomic molecules. Yes, it's correct because they exist in the as diatomic form. We have already discussed that previously. Chlorine displaces both bromine and iodine from its aqueous solution. Yes, it's right. We have already done it because we have already discussed it. Okay. The halogens become more reactive on descending group 7 of the periodic table. No, they become less reactive as we go down the group. Okay, so 1 and 2 option would be the right one. Which two statements indicate that metal M have a proton number between this 21 and 30? So that would definitely be a transition metal, and we have learned that transition metal would be having the property like they form they have variable oxidation state. That is why they would be forming like here they are forming M plus 2 and O minus 2. That would become MO. And here it is having M plus 3 and O minus 2. That is why it is forming M2O3. So the option would be 3 and 4. Okay. So there are some P2 questions that I have also included in this worksheet. The periodic table is an arrangement of elements in groups and periods. What are the factors that determine the position of an element in the periodic table? So we know that there are basically two things which define the position of element in the periodic table. The first is number of electrons in the valence shell because that determines that whether the element is present in which group because the like the number of electron in the outermost shell tells us the group number. Second one is the number of electronic shell because that would indicate that in which period that particular element is present, electronic shells. So these are two things that would define us with this thing. Use the information in the table to suggest the density of selenium at room temperature. So if you see about the density that is increasing, like this is increasing, like plus 2 is there, then we can see that this selenium density should be present between 2.1 and 6.2. So that should be around 4.1. So the answer should be 4.1. And then we have use the information in the table to decide the physical properties of oxygen at minus 190. So if we see oxygen that has a melting point of minus 219 and that has a boiling point of you can say minus 183. And now minus 190 should be present like here because you can see that minus 190 is basically the you can say the temperature that is present around here. Above this point, this is basically the boiling point and this is basically the melting point. So above the boiling point, they exist as gaseous state. And here, below this temperature, they would be existing as solid state. So between them, they would be existing as liquid state. They would be existing as liquid state as the temperature is between the melting point and boiling point. So you will write here that it would be existing as liquid state as the uh, the minus 190 degrees Celsius is present between melting point and boiling. Okay. So let's move further towards the next question. Describe the trend in the electrical conductivity of group 6 elements. So electrical conductivity is this one. So if we go down the group, we can see that uh, electrical conductivity becomes from very poor to good. So we can say that electrical conductivity increases. Electrical conductivity increases as we go down the group. As we go down the group. Then we have, there's a trend in the melting point of group 6 element. Which element does not follow this trend? So if we say melting point of group 6 element, let's see melting point, yes. So which doesn't like follow the trend. So it is increasing, increasing, and then it is decreasing. You can see the melting point increase from top to bottom, but then there is a decrease in the melting point of polonium. So we will say the element is polonium, and we will say that uh, melting point of polonium suddenly decreases. Suddenly decreases. That is why it doesn't follow any trend. It does not follow trend. Okay. So this is all about today's video, and I hope you have liked it and you have learned a lot from this video. Please do subscribe and like, subscribe my channel and like this.